Check it out now, y'all.
Nano Hub U, online instruction.
So welcome to tutorial 3 of week 2. And if you remember, the last 2 tutorials, I guess, the first one was about this density of states. And then we talked about this conductivity as a function of the number of electrons. And this particular homework, this number 3, that's about finding the number of modes. That, as I've stressed, is a very important concept. That while density of states was a concept that's been with us since the earliest days of solid-state physics, the number of modes is a relatively new concept that only became important with the rise of mesoscopic physics back in the 1990s. Now, when it comes to this number of modes, there are these 2 ways of looking at it that I discussed, and it is often not clear that those 2 give you the same result. And I guess this homework sort of takes you through a specific example showing you that those 2 give you equivalent results. So here what we are considering is something with the energy-momentum relation that's given by this. And I gave you 3 energy-momentum relations, but as you know, the first 2 are kind of like special cases of this third one. So that's the one we are working out. And if you want to do the number of modes, so this is in 2 dimensions, the general expression for number of modes is this h dv over 2L, and times a factor that depends on the number of dimensions. And for 2 dimensions, that number is this 2 over pi. And so what we could do is, so that cancels, so that's what we have. Next, what we want to do is substitute for d and v from the results that we have done already. So we could write, so this is, let me collect the constant things on one side, h over pi L, and then I have the d, which is 2 pi W L E over h square V0 square. So that's d. And then v, that's the velocity, which is defined as the slope of energy with respect